This is a demo recording we did for the RedHat Summit. So here we're going to showcase RDO and OpenDaylight integration. So this is the high-level slide showcasing the OpenDaylight's integration that is performed with OpenStack. This demo we are specifically concentrating on the RDO distribution with Packstack as our deployment vehicle. Packstack is a tool for developers to test the RedHat distribution, which is a straightforward tool to start deploying and seeing how OpenStack works in a constrained environment. OpenDaylight is an open source project for addressing various use cases for networking. One of the editions is called the virtualization edition of the Hydrogen release, which happened in February of this year. For OpenDaylight, Neutron is an application, and we have developed the OpenDaylight ML2 plugin, which uses the OpenDaylight's northbound APIs to create networks, create subnets, create virtual ports. Essentially, using the simple northbound APIs, OpenDaylight is able to provide a service for the OpenStack to do the network virtualization. At a high level, we have the OpenDaylight has a layer called ADSAL, which abstracts the southbound plugin from the northbound layer, which is pretty efficient for an application like Neutron, because Neutron doesn't care about which protocol is actually being used for the actual transport. And we have layers for various services that SAL expresses. And on the southbound, we have the OVSDB and the OpenFlow plugins, which provides the appropriate services. OpenFlow is used for programming the flows, while OVSDB is used for doing the tunnel orchestration. For any questions regarding how to set up RDO with OpenStack, you can refer to the RDO wiki, which has all the detailed instruction on how to do the OpenDaylight integration with RDO. We also mention it in one of the slides here. From the architecture again, the OpenDaylight expresses their Neutron REST APIs, which the ML2 plugin calls. And in this demonstration, we are going to use a simple two plugin approach, which is the OVSDB southbound plugin and OpenFlow southbound plugin. In Hydrogen release, we support both 1.0 and 1.3 OpenFlow mechanism. But in this demo, we are going to stick to the 1.0. For this demo especially, we have the following topology, where we have OpenDaylight controller running in a separate VM, and OpenStack, especially RDO Packstack based deployment, we are running it in a separate 3 VMs. So we have this OpenStack control node running in one VM, and we have 2 more compute nodes running as 2 separate Fedora VMs. As you can look at it, we have 2 separate networks. One is the management network and the data network. The management network is used for both the OVSDB and OpenFlow connections, while data network is used for the actual tunnel overlay. Quickly, let's go back to the actual terminals, which is the backend terminals for OpenStack and the OpenDaylight. Let's start the controller. So the top left corner, this is the OpenDaylight controller. So we start the controller. It takes a few seconds for it to start. Let's switch back to the slide here. So the moment we start the controller VM gets spun up, and we'll execute some scripts on these compute nodes, which can be a Puppet enabled script where it will start connecting to the controller via the OVSDB channel, and from there on the real thing starts, where the controller sets up the bridges, sets up tunnels based on the VM configuration, so on and so forth. So the controller is up and running now, and the control node is the OpenStack Packstack control node, and the compute, we have 2 compute nodes, compute 2 and compute 3. Before we start the actual integration between ODL and the OpenStack, let's look at the existing bridges that is created by Nova and Neutron on the compute nodes in the controller node. This is the dump flow. There's no flows there. That's good. Oh yes, VSCTL. Sure. Right. This is the command to show the bridges that is present there. So there's the br int and brex, and you look at the same commands in the compute nodes. You see that there are no flows created by the controller, and let's look at the bridges. As you can see, the compute nodes have the bridge br int, and the control node has the bridge br int and ex for the external connectivity. Now, in order to get started, the OpenDaylight integration with OpenStack is an agentless configuration where there's no agent for OpenDaylight running on the compute nodes. Since we use OVSDB as the open protocol to communicate, we need to have the OVSDB connection between all the compute nodes and the controller, and the OpenDaylight controller. This can be automated using Puppet scripts, but for now I am having a simple script which will do it for me. So this is the script that I'm going to execute now. So the moment I execute, when I try the print nodes command, see that I see a OVS connection. Along with that, there are other open flows. There are 3 open flow nodes here. Originally we saw only 2. So now when you look at the ctl command, you see that in addition to the br int and brex, you see the br tunnel also, which is actually created by the OpenDaylight controller in order for the tunnel orchestration. So this is done using OVSDB, and let's do the same thing on the compute nodes. So let's go here, and here it's the 103 and 104. The 104, 103, they are the local IP configuration needed for the tunnel endpoints. Now when I go to the show, you can see that BR tunnel is created on both these bridges as well. And now look at the flows. You can see that we have automatically created 2 flows, the normal and the LDP flows here. Same for all the compute nodes as well. There you go. Now the key thing to note here is from an OpenDaylight standpoint, it doesn't differentiate between the control node and the compute node. It treats them everything as a data plane and installs a similar kinds of flows to each one of them. Now when you go and look at the print nodes with all the nodes connected, you will see there are 3 OVS instances: OVS1, OVS2, and the third OVS. So 3 compute nodes in this case, one is the control node and then 2 compute nodes, all are created and automatically creating the open flow channels as well. Now let's go to the controller's UI. There you go. Now as you can see, the UI, it has automatically detected all the bridges, so BR int and BR tunnels that we just saw on these compute nodes on the controller node, and all are now just the UI as a nice UI which will represent the graph once you start seeing things. So the connection between the BR int and the BR tunnel, it's actually the patch port that we establish automatically when we create the BR tunnels, and the BREX is also there, which is not connected to any of the bridges at this point. As you can notice, the BR tunnels are not connected yet because there are no tunnels being created yet by the controller. As you can see here, even though the BR tunnel bridge is available, there's no tunnel port created here. That's because the OpenDaylight controller is smart enough not to unnecessarily waste resources until there's a need for that. So the actual need for creating the tunnel in this case is that we need at least presence of VMs on appropriate hosts. Since there are no VMs that we have created so far, there's no tunnels being created. That's why you see that the connection is only between the BR tunnel and BR int on each compute node in this case. Okay, now let's get started. In this demonstration, we are going to create 2 tenants, Coke tenant and Pepsi tenant. So for interest of time, I'm just going to create using the command lines which we have available there, called the keystone command on the control node. So you can do a keystone tenant create name Coke. It creates a Coke tenant and Pepsi tenant. Also, let's create some users for these tenants. So I'm going to call them Pepsi and Coke users. It's the same name, and we can also give them admin privileges so that we can start seeing things pretty elegantly. Now we created the users, we created the tenants as well. Now let's take time and log into the OpenStack UI. Actually, let's log in as admin now, which is an overall admin for the entire OpenStack. Here we will be able to see all the projects that is created. In this case, since we created the Pepsi and Coke, we see all of them here. But for the sake, I'm going to sign out and log in back as say a Coke user, for example. So Coke has logged in, and if you look at the project, the only project is capable of seeing is the Coke project, and we haven't created anything else. When you go to network topology, you won't see anything because we haven't created any network for this Coke user or the Coke tenant. And let me also log into the Pepsi user. We see similar thing there. Pepsi user can see only the Pepsi project, is a tenant essentially, and the network topology here will be empty as well because there's nothing to be shown here. Now let's go back to the command line, and we have a simple command to create a network. So here we have this neutron network create command where you can do a I'm going to create a GRE command network stating that, hey, please create a GRE network for me for a segmentation ID 592 and for the user the Coke for the Coke tenant, and also create a subnet for 10.2.10.10 for the Coke tenant. I'm just going to copy paste it here. So it takes a few seconds and then it creates the network and also creates the subnet as well. Similarly, let's go and create a similar one for the Pepsi, and this time we're going to allocate only in the Pepsi tenant. It also creates the subnet for the Pepsi tenant. So it's created. If we go back to the OpenStack UI and let's do a refresh here, you see that for the Pepsi user, you see the Pepsi GRE network only. You don't see the Coke GRE here. I can sign out and let's log in back as Coke. And if you look at the network, you see the network created for the Coke user or the Coke tenant. But what is to be noted here is when you go to the OpenDaylight, you still won't see any difference here. That's because there's no VMs have been still spawned. We just created the network. There's a provider side thing which is nothing to do with the actual resources being used yet. So OpenDaylight is not reacting on the network creation events yet. Now, the interesting part. Let's start launching VMs on these tenants, and now we'll start seeing that OpenDaylight controller will start create these overlay GRE networks and start orchestrating the stuff for us. Let's launch a SOS instance on the, now we are in the Coke tenant. From the UI, let's create Coke VMs, let's call it Coke VMs, and create say 2 VM for example, and let's boot from an image. I have a very small image called the Cirrus image. It's a 12.5 meg. As you can see, it can do very basic stuffs. The networking, as you can see, is the Coke user will see only Coke GRE network that's created for the tenant. Click the launch. The launch typically, or the Nova takes the command and start launching these VMs. And since we also provided the GRE network, it is going to attach to this GRE network. So it takes a few seconds. In the meantime, let's go and look at the backend commands on the. Let's see what OpenDaylight has done for us. As you can see here, the OpenDaylight has actually created this GRE network between the compute nodes 102 and 103, and 103 is here. When you look at the show commands, you see that it has created the tunnel between these two. And when you go back to the OpenDaylight and do a refresh, you see we will see the tunnel between the two endpoints is created because this GRE has been created yet. And as you can see, the compute node 3 is not connected to any of this network because the VMs we haven't launched yet on this particular compute node 3. Back and create a similar kind of tenant instances for the Pepsi user as well. Logged out, logged in as Pepsi. Let's go to the project. Network topology. You see that there won't be any VMs because this is we just created the network. There's no VMs launched on this tenant yet, and let's also launch 2 VMs here. Let's launch Pepsi VMs. Let's do 2 counts and image, Siddhar's image, networking, Pepsi, and launch. So now Nova is going to do the actual algorithm here and figure out where are the resources available, and then it's going to launch the VM on the appropriate nodes. Now it's possible that it might launch it on the compute node 3 so that we can see the actual tenant established between the compute node 3 and some other compute node based on the VM placement. Just wait for a few more seconds and you will start seeing the VMs attached to this network here. And as it launches, we can again go back to our backend and there you go, right? So as you can see here, it has actually created one more VM tunnel between the compute node 1 and compute node 3, as you can see here 104, and the key is differentiating here. 592 is for the Coke VM and 768 is for the Pepsi VM. And ideally, yeah, you see it here as well. So now the tunnel is being created between these 2 VMs. And ideally it's been done here as well. Yeah, it's one of the VMs has been launched, other one is being launching as you speak. So as that goes on, let's look at also the dump flows. As you can see here on the BR int, we don't create any other flows other than the punt and the normal. But when it comes to the BR tunnel, we actually do the flow programming across tunnel forwarding and so on and so forth. So all the traffic going across the network takes this tunnel and then gets forwarded using the OpenFlow configurations. Now let's go back, and as you can see here, the VMs are launched, and let's go and refresh on the OpenDaylight. You see that the one more tunnel has been established between the compute nodes. So it's clear that the OpenDaylight controller has the smarts to not create the tunnel willy-nilly on all the compute nodes. Rather, it creates the tunnels only on the required bridges, only on need basis. The need is actually the presence of the VM. So we're back into the Pepsi VM, and you can see that both the VMs are launched, and so one of the VM is assigned 10.2.10.2.3 IP address, while the other one is 10.2.10.2.2 IP address. This is as per the DHCP agent representing the information. And let's open the console, which is the VNC console for one of the VMs out there. This is the 210.2.3, and let's log in to Ceros cups win and smiley fconfig. You can see that the IP address is exactly as it's been represented here. That means DHCP is working fine. And let's do a ping to the next neighbor, which is 210.2.2. Right. The ping works fine, right? So even though it's in the OpenStack UI, it shows as if it's the neighbor in the same network. Actually, they are neighbors across the GRE tunnel in 2 different nodes, and the entire OpenFlow on the GRE has been orchestrated using OpenDaylight, which is exactly the tunnel that we are representing here. So OpenDaylight and OpenStack, they work hand in hand. While OpenStack provides you the high-level picture of the network, while OpenDaylight does the hard work of actually making the network happen. So that pretty much concludes the demo. For more information, please refer to these pages where the RDO has a pretty cool pack stack which you can just download and start using it in Fedora or Red Hat Enterprise Linux. OpenDaylight, a lot of good material in OpenDaylight.org, and the integration specifically, you can look at the link here, which will talk about this integration, this demo that we expressed right here. And thank you.